All right, so PDF, probability density function. It's density. It's not the same as probability, right? It's flow rate. So we want to create this connection of like, well, how do I see the connection between the curve itself and the area under the curve? So we're going to go back to something we already looked at last lesson. Suppose I have legal values for my continuous random variable. My random variable can take on any value between -5 and 5. And for whatever reason, I believe that this function here, or some variation of this function, would do a good job modeling out a phenomenon that's interesting to me. We noticed that we have to have two rules, right? Rule number one, the PDF, the curve, can never fall into negative territory. And rule number two, the area under the curve has to equal 1 because the area under the curve is total probability, and probability can't be more than 1. So let's fix the first problem. We've already done this. When x is 2.5, y hits its negative value of -6.25. So as long as I add a value at least 6.25 over my legal range of values for x between -5 and 5, then I'm good. Now from here, I'm going to see, well, what is the current area under the curve between x equals -5 and x equals +5? To do that, I just put in int, and then I put in -5 tab 5, and now I'm going to the integrand. I'm going to put parentheses here, and I'm just going to take the PDF, because what this integer or integral does for us is it calculates the area under the curve. I put in a dx, and I get a value of 145.833333. Remember, I want my area to be what? I want it to be 1, so I can go out front and I can say 1 divided by, copy, paste, and now it equals 1. So here's the wrinkle, okay? The wrinkle is that my PDF has to be modified. It has to be changed. We've already modified it once by adding 6.25. The other thing that I would need to do is to divide everything by 145.83333. So 145.8333333. And this is now my new integral. So what I want to show you from here is how the whole probability bit works. And let's get our intuition. Remember, x can only take on values between -5 and 5, right? Let's go on up here and let's make x-axis equal -5 to +5. And the entire area under the curve along this range is 1. Notice that almost all of the area under the curve lives pretty far to the left in the example that we've taken. I mean, there's a little bit as you go farther and farther to the right, but not very much at all. So we can change this up and turn it into a probability just by changing the upper limit. Instead of going 5, why don't we go 3? And now this is saying what's the total area under the curve between -5 and 3, and we get 0.96457, which is to say that if our PDF were this, monster up here, then the total area under the curve from x equals -5 up to x equals 3 is 96.45%. Why don't we go down to 1? Well, we really didn't gain much. We're at 95%. How about to 0? 92%. How about to -1? I'm sort of going backwards. 86%. You know what? I can do better. Let's do this. Let's take a slider. I'm going to put C and add a slider, and I'm going to put in for that -5 up to 5, because those are the legal values that I can take. We'll do it in increments of like 0.01. And as I move this slider to the left or to the right, I see the probability of, say, like, well, what if my random variable, what's the probability that it takes on a value between -5 and -2.9? Well, there's a 60.4368 chance that that is what's going to happen. So that's the link between the PDF, the curve, and the probability, which is the area under the curve.